Okay. All right. So this is going to be page 33, okay, in our notebook. So we're going to look at a quadratic and its inverse, okay? Okay, so it says for the given graph, draw its inverse. Before I do that, I'm just going to actually just graph the original one in Desmos. We should know what this equation is, right? It's our quadratic parent function. Y equals x squared. Okay. Before I draw its inverse, I'm going to come down here and answer these questions. What is the domain and range of the quadratic? Okay, good review. Domain, remember that's x values. The x's in a quadratic can be all real numbers, right? However, the y's, our range, that's not the case. For the range, we're looking at from 0 to infinity. I'll just put y is greater than or equal to 0. Okay, now I'm going to minimize Desmos for just a second, and I'm going to put the inverse on here, okay? And we had a question like this last week where we took a parabola and made its inverse. Remember, to do inverse, you are just grabbing some points and switching x and y. So if I have the point 0, 0, and I switch x and y, I still get 0, 0, right? That's the point 1, 1. If I switch x and y, I still get 1, 1. What other point is on here? This point is, 2, 4. So its inverse would be 4, 2. So let's graph that. 1, 2, 3, 4, 1, 2. And I think we can get one more. I'm going to take this one. That's the point 3, 9. And if I switch x and y, I get 9, 1, 2, 3. Okay? And then on the quadratic, we have all of these reflection points, right? Or symmetric points. We reflect over the y-axis. Well, in the inverse, I wouldn't reflect over the y-axis. I would reflect over the x-axis, right? Because x and y switch. So a quick way to get those other points is to just reflect 1, 2, 3, 1, 2, 3. And don't worry on this particular question if you're having trouble putting the right points on there. A sketch is okay, because you'll see the part that I want you to see here. Okay. So our inverse domain, well, if x and y switch, then domain and range also switch, don't they? The inverse domain ends up being the range. So our x's go from 0 to infinity, or x is greater than or equal to 0. And the range, well, I have one arrow going up, I have one arrow going down forever. That's all real numbers. Okay, but here's the big question. Is the inverse, the one I graphed in red, is that a function? Does it pass the vertical line test? No, right? It fails. This is not a function, okay? So let's take a look at how we can make the equation real quick. Okay, I'm going to do that up here. This is our equation, y equals x squared, right? Oh, this pen is dead. Don't use that pen. Let's use blue. Y equals x squared. And if I want to find the inverse, wouldn't I switch x and y? And then to get y by itself, I would do the opposite. Well, the opposite of square is what? What's the opposite of squaring something? Square root, right? Remember that? Okay, so I'd square root that to get rid of my square. And the square root property says when I square root an equation, I have to take both the positive and negative square root. So the equation for this red graph is plus or minus the square root of x. Okay? So I'm going to put that into Desmos so we can see it. Okay? So I'm going to put y equals, to do a square root in Desmos, you can either find the button or you can type, and I wrote it on the board, SQRT. And when you type SQRT, a square root comes up. So Desmos can't do plus or minus. Okay, that's not in its power. So I have to do two separate equations. So I did y equals the positive square root of x, and now I'll do y equals negative square root x. Okay? And it made it two different colors. I could change the color if I want, but I don't really care that much. Okay? All right. So this matches what we have drawn here. Here's the big question. How would we need to restrict the x values of the original? What's the original? The original is the quadratic. Okay? How could we restrict those x values so that the inverse is a function? Because right now my inverse is not a function. Well, I had to type my inverse in two separate pieces, right? So let's say I'm just going to take off one of the pieces, okay? The red graph. Just look at my red graph here. Is that a function? Does that pass the vertical line test? Yeah, it's a function now, right? When it had the other piece, that's not a function. But that is a function. Okay, now if I wanted to look at what its inverse is, the inverse of the red function, it's not going to be the whole parabola, right? It's only going to be part of it. So what part of it is the inverse of the red function? That's a hard question to answer, isn't it? There's a way I can cut this in half, right? What if I'm going to go back here, and I'm going to cut it in half at its vertex. Okay? Its vertex is when x is 0. So what I'm going to do is I'm going to say I want the parabola, but only for x's greater than 0. So here's what I'm going to do. I'm going to type in that curly brace, like a solution set, x greater than or equal to 0. Okay? And I can end it with that. Now when I type that, only one side of the parabola is shown, right? Because I told Desmos, hey, I want this function, but only for x is greater than or equal to 0. Now, does that look like an inverse? And honestly, you might not know yet, but you can also type in the reflection line, y equals x. Does that look like a reflection over that line? Yeah. So we want this function, but only for x's greater than or equal to 0. Now let's say we were wrong and we did the wrong side. Okay, so I'm going to change that to less than or equal to 0. It's going to look weird. It'll look obvious. That's not right, right? That's not a reflection over that line. Okay? So I think, well, what side of the quadratic do I need? Oh, I need the side where x's are greater than or equal to 0. Okay, so back here to answer our question, how would we need to restrict the x values of the original? Restrict the domain of y equals x squared to x is greater than or equal to 0. In other words, we just want one side of the parabola. I just drew a little parabola there. Now if we only look at one side and we find its inverse, well, that gives us our new function that we're going to be talking about, and that's our square root function. So this is our new parent function, square root x. It's the inverse of a quadratic function over a restricted domain of x is greater than or equal to 0. So this right here is our square root function. This table is just for me to fill out the values of the points that are on the graph. So if I take a look, that first point at that vertex is 0, 0. And then I have a point at 1, 1. And then I have a point at 4, 2. And if you think, okay, this is the inverse of a quadratic, 3 squared is 9. The square root of 9 is 3. So the next point there would be 9, 3. Okay? The domain of this function, remember that's x values. Well, our x's begin from here and go to the right. And what's this x value? Oh, 0. So x is greater than or equal to 0. Or if you like interval notation, then write it like that. Range, remember that's the y values. So the bottom is right here, and that y value is 0, and it's going up into infinity. So y is greater than or equal to 0, or 0 infinity. Okay. So in a nutshell, we'll just fill out what we mean with domain restrictions right here. So inverses. Inverses interchange the x values and y values. This results in the blank of the inverse functions, also interchanging the domain and range. When you switch x and y, you also switch the domain and the range. The domain of the original function becomes the range of the inverse. The range of the original function becomes the domain of the inverse. Blank may be used to ensure that the original function and its inverse are in fact inverses. Oh, domain restrictions. Okay. That word is restrictions. I know it's kind of weird. Okay, now remember, for us to figure these domain restrictions out, we have a very powerful tool. Okay? Desmos is amazing. You can figure all of this out with Desmos. Okay? All right. So now we're going to take a look at two different examples where we're going to analyze them totally. So we're going to graph them, find domain and range, do the inverse. Okay? Don't mind these random things. This should just say greater than or equal to 0. I had tried to put a box over that and change it, but the formatting messed up. I'm sorry. Okay, so we're going to find the inverse of this function. So this is a quadratic, right? But it's giving me a domain restriction, so it's telling me only part of it. But you know what? We can type this directly into Desmos, so let's do that. Okay, just going to clear out everything that's here, start fresh. So y equals x squared plus 3 Okay? But there's also a domain restriction here. So when you go to type the domain restriction into Desmos, remember what you use is you use the little curly brace. Okay? We don't write that, but we have to type it. Okay? X greater than or equal to 0. And then it shows us 1/2 of the parabola, right? Okay. Now I want to put the graph on the paper so I can just hit this little wheel and hit table. And then I got some points. They're very nice, and I can just plot those. So 0, 3, 1, 2, 3, 1, 4, 1, 2, 3, 4, and 2, 7. 1, 2, 3, 4, 5, 6, 7. Okay, and I could get more, right? I could keep the table going if I wanted to, but I'm not going to be able to fit anymore, so this is enough, okay? And we're going to label that f of x because that's its name. Okay. Now let's figure out its domain and range. Remember, domain is x. So where do my x's begin? The farthest left is this point. That x coordinate is 0. So we can say x is greater than or equal to 0. Oh, and obviously, like, we're told what it is, right? We typed it that way. Range is y. So I look at the bottom. This point is also the bottom. Its y value is 3. So our y's are greater than or equal to 3. Okay. We all good with this part? I literally just typed this into Desmos and got some points. That's it. Okay, now I want to find the inverse. And these are the steps. Remember these steps from last week? They are the exact same steps. Okay? So we're going to figure out its equation for this inverse. So first thing we do is rewrite the f of x as a y. So this is going to turn into y equals x squared plus 3. Now, I kind of ignore the domain restriction for right now. It's not really part of my inverse. We'll just talk about, we got to come back to that in a second, okay? So this is our equation. Now we can switch x and y. So literally just switch the x and the y. So we get x equals y squared plus 3. Okay, so once we switch x and y, now we solve for y. We want to get y by itself. We work from the outside in. So first, we're going to minus 3. So x minus 3 equals y squared. Okay, now I need to get the y by itself. We've already talked about the opposite of squaring is square root, right? So I square root. And look what's on the left side, x minus 3. So this whole thing goes under a square root. I square root the whole thing. So you just draw a big square root. But when we square root, we take the plus and minus, right? Okay. But now we got to think. Plus and minus isn't a function, right? I just need one of those. I either need the plus, the positive square root, or the negative. Now, how do I decide which one I use? How do I decide that? Well, that's when we go back to the domain restriction. It tells you if you want the plus, the positive square root, or the minus, greater than 0. Does that describe positives or negatives? Numbers that are greater than 0. Those are positives, right? So that means I want the plus square root. If that had said less than 0, then I'd want the negative square root, okay? So I want the positive square root. So now in function notation, I change my y to f inverse x equals the positive square root of x minus 3. And I make sure that the whole thing is under the square root, okay? Now let's make sure that that's right. I'm going to go back to Desmos. I'm going to get rid of this table just for a second. And I'm going to type this in. Y equals SQRT x minus 3. Okay. And then I look. All right, do those look like they're inverses? I can throw on the reflection line. Yeah. Now if I messed up and I accidentally picked the minus square root, it's going to look wrong. Okay? So you can check yourself. If you're not sure, you can just look at it. Okay, so that's the right one. Now how do I make the graph? Well, you can turn this into a table. But honestly, it might just be easier to take these points right here and switch the x and y. So 0, 3 turns into 3, 0. 1, 4 turns into 4, 1. And what is that? 2, 7 turns into 7, 4, 5, 6, 7, 2. So we get this guy right here. And that's our inverse, so I'm going to notate it like it's the inverse. Okay? So this is saying domain of f inverse. This is just saying what's the domain of the inverse. Well, you can figure it out, or you can use what you know about inverses. The domain of the inverse is going to be the same thing as the range of the original. So x is greater than 3, or equal to 3. And the range will be the same thing as the domain of the original. So y is greater than or equal to 0. So what did we do here? We just analyzed a function and its inverse and just gave all the things. Okay? Yes? Emergency? Yeah. Okay, that's fine. Okay. Any questions I can answer for you? All right, let's do something similar, but we're going to do the reverse. So we're going to start with something, with an original that is a square root. All right, let me clear out Desmos real quick. I'll start over fresh. Okay. So now I'm going to type my new original. So I have to be very careful that plus 4 is not under the square root. So when I type it in, I have to make sure that that plus 4 is not under the square root. I want to match my pen color. I'll make this one blue. Okay, so there's my original. For me to graph it, I can just hit year, table. And I can get some points, so I can do 0, 4. 0, 1, 2, 3, 4. And 1, 5. And I need some more points than that, so I'm just going to add some more. There we go, I got some good points. I got 4, 6. I can graph 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And I think I found another good one, 9, 7. So 9, 1, 2, 3, 4, 5, 6, 7. There we go. Okay, so how am I getting that? I just used the table and I just took all the nice points to plot. Okay, let's figure out its domain. Remember, domain is x, so farthest left is this point right here. That x coordinate, the x is 0. So x is greater than or equal to 0. The range is the y. So the y coordinate there is 4. So our y is greater than or equal to 4. All right. Now we can begin the process where we are finding the inverse. Okay? So I'm just going to follow these 4 steps. First, take our f of x and write it as y. So y equals square root x plus 4. Then we can switch x and y. So you literally just switch x and y. The square root doesn't move too. Just the letters move. They just switch places. Okay, now we solve for y. We want to get y by itself. So I work from the outside in. First thing, I'm going to subtract 4. So we have x minus 4 equals the square root of y. Okay, I have square root of y. How do I undo a square root? Opposite of square root. Square, right? You square a square root, they cancel. So what I do is I grab everything on the other side, put it in parentheses, and square it. Because all that is going to get squared. And then I rewrite in function notation. So f inverse x equals parentheses x minus 4 squared. Okay? Okay, now, let's look at it in Desmos. Let me get rid of my table for a second. Don't want the table anymore. Let me type that in Desmos. Y equals parentheses x minus 4 squared. Okay. Do I want the whole parabola? That doesn't look right, right? I only want one side. All right. So we have to figure out, well, one, what side do we want, and then how do we say that or write it or type it? Like, how do we notate? Well, where you cut the parabola in half is right here at the vertex, right? So you can click it, and its x value is what cuts this in half. So we either want the x's that are greater than 4, or we want the x's that are less than 4. And to figure it out, you can just try it, right? So let's try the x's that are greater than 4. So remember how we do that, how we do a domain restriction. You type a little curly brace, x greater than or equal to 4. And then just ask yourself, does that look right? Does that look like a reflection? Yeah. Okay? And if it's wrong, let me do the wrong side for a second. It's very clearly wrong. It looks weird. Okay? So this means we have to add this to our answer. The inverse is not just the parabola, but it's x minus 4 squared for x's greater than or equal to 4. That is part of the equation. Without it, it's not really the right inverse. Okay. Okay, then how do we put the graph on there? Again, you can switch X and Y, or you can hit gear table. Let's start it for, whoops, I thought this was going to do it for me. 5, 6, 7, okay. These are going to be the exact same points we had on the square root function, just reversed, right? So 4, 0, 5, 1, 6, 1, 2, 3, 4, and 7, 9. Okay. So there's our inverse. And then for the domain and range of the inverse, it's just this switched around, right? Domain of this will be 4 to infinity. Or sorry, no. Yeah. X is greater than or equal to 4. And then our range of our inverse will match the domain of the original. So this will be y is greater than or equal to 0. Okay? All right. How are we feeling so far? These two examples, we were doing all the things. Okay? All the things. You don't always have to do everything. Okay? The part that I really want to hone in on is this stuff. How do we make the inverse equation? So let's just take a few more examples and just do that step, that part. Not everything else, just the equation part. Okay? I have a little bit of a typo. That should be x is greater than or equal to -5. Okay, so we're going to find the inverse algebraically. All right, so we're going to apply these steps. Step 1, rewrite with a y equals. You know what? I'm just going to write y above this. And then I'm just going to go right to the switch x and y step. So switch x and y. So this becomes x equals parentheses y plus 5 squared. Now remember what this guy is. This is the domain restriction. We just kind of ignore him right now. Okay? All right. Now I want to get to y. I don't minus 5 first because this whole thing is being squared. So I have to square root. Plus or minus square root. All right. Now, do I want the positive square root or the negative square root? That's when you go back to your domain restriction and you look at the symbol. If x is greater than, that's the positive side. If x is less than, that's the negative side. So this is a greater than symbol. So that means I want the positive side. So I want the positive square root. So positive square root of x equals y plus 5. And then I just minus 5, right? So I get the square root of x minus 5 equals y. Now, I've got to be careful. This minus 5 needs to be outside the square root. It doesn't get to sneak in under it. The minus 5 happened after we had already square rooted, so it doesn't get to be part of that. Okay, and then we write in function notation. Our original function was named f, so our inverse will be named f inverse. Okay. And there we go. Now, if I wanted to check, for time, I'm not going to type them all in, but I could type this in, right? Just like I was doing the others. I could type this in with its domain restriction and this to see if they appear correct. Okay. Okay, B is going to be interesting. Okay, there's a negative in front of that square root. Ooh, all right, let's do this one. So f of x is y, right? Now we switch x and y. So x equals negative square root of y minus 2. Okay, I want to get y by itself. Remember, you work from the outside in. So the most farthest piece of this is this negative out front. So the first thing we would do is undo this negative by dividing by -1. That'll get rid of that negative. We divide x by -1. So we have negative x equals square root y minus 2. Okay, before I can get rid of the 2, see how it's all under the square root? So I have to cancel out my square root by squaring. And then I have to take everything on this side and square it. Okay, now when I square a negative x, isn't that just positive? If I square a negative, that's positive. So this is really just positive x squared equals y minus 2. And then I can just add 2. Add 2 there. I can add 2 here. So x squared plus 2 equals y. All right, now I have to do my inverse function notation. F inverse x equals x squared plus 2. I think I'm going to have to graph this one, though, because this is an entire quadratic. And remember, we are not going to use the entire quadratic. So let me put the original on here. Y equals negative square root x minus 2. And then my inverse, y equals x squared plus 2. Okay, so I'm not going to be using the entire quadratic. I got to figure out what side and where do I split it. Okay, you split it at the vertex. So where's the vertex? Right there. And I look at the x. So I either want the x's that are greater than 0 or less than 0. So I can type it in and see x greater than or equal to 0. Does that look right to you? Let me throw my reflection in there. No. So let's try the other side. Let's do x is less than or equal to 0. That looks more like a reflection. Anybody know why it has to be less than 0? Why was this one less than 0? Hint, you got to look way back at the original question, the original equation. Exactly, because it's a negative square root. That's why we use the other side, okay? So x is less than or equal to 0. That's the full answer, okay? Okay. There's nothing different or weird about C. I just want you to try it, okay? So you try applying these 4 steps to make the inverse, and then we'll go over it in just a minute, okay? That's y. X equals y squared plus 6. Switch your x and y. get y by itself. So minus 6, x minus 6 equals y squared. Okay, when y'all get to this step, after you've switched x and y and you start getting y by itself, so you subtract 6, we square root. Square root property says you have to do plus or minus square root, but we know we're not going to, right? We're just going to take one of those. So do we want the positive or negative square root? Remember how you can tell from the problem? I mean, you can certainly type it in and see that way. Do you know how you can look at the equation to know which positive or negative you need? You look right here. Greater than we want positive, less than we want negative. So I want the positive square root. So positive square root of x minus 6 equals y, and that's our inverse. So we write it with our inverse function notation. And yeah, I mean, we could graph it to get the you know, to be sure. Okay.